What are some common mistakes people make when making data-driven decisions? As a data scientist, I've made my fair share of mistakes. There are 3 common categories of mistakes that are easy to make: information gaps, drawing conclusions too early, and biased decision-making. Let's look at each of these in turn. Information gaps occur when the data available doesn't represent the entire story. When this happens, we tend to add values or assume trends, and this is called extrapolation. No, it's not a magic spell. Because the human brain looks for patterns to find solutions, we tend to extrapolate in order to find the missing pieces when examining data that has information gaps. Making decisions with information gaps can often lead to biased samples, or quite simply, cause us to draw conclusions that are beyond the scope of our data. Let's imagine a pile of pancakes. Say we want to know how much our customer would pay for 12 pancakes. We have data on what people will pay for 1, 3, and 6 pancakes, and the trend seems fairly linear. However, we have no data beyond 6 pancakes. Extrapolating from our data that a customer is willing to pay the same price per pancake at 12 pancakes is probably a poor assumption. Another common mistake when making data-driven decisions is drawing conclusions too early. This is an easy thing to do. Here we present 3 common examples of drawing conclusions too early. The first is overlooking regression toward the mean. Regression toward the mean is a phenomenon that any extreme values in our data will generally be followed by values close to the mean. Imagine a luxury watch seller or authorized dealer. Over the past 4 years, the seller has sold an average of 50 watches per month. In January, they sell 300 watches. This leads them to conclude that an inventory of 300 additional luxury watches will be needed for the coming month. What the seller failed to recognize is the regression toward the mean phenomenon. This huge spike in sales will most likely be followed by a month closer to the mean value. The second mistake is that correlation does not equal causation. This is a phenomenon whereby a relationship between 2 variables increasing together does not imply that one causes the other. For example, ice cream sales are highly correlated with swim trunk sales. Now, this is clearly not due to the fact that one causes the other. We can't increase our swim trunk sales by ensuring that more ice cream is sold. What is really happening in this situation is that when the weather gets warmer, both swim trunk sales and ice cream sales will both increase. Always be careful not to assume that correlation equals causation. The third and final most common mistake is biased decision-making. This is the tendency to base your conclusions on preconceived biases and small pieces of outside information. Whether all of the data is available or not, biased decision-making can often occur when data is overlooked because the previous data was accepted early on. This can make it difficult to form opinions on new and potentially more relevant data. Let's imagine a patient trying to pick the best doctor for his upcoming surgery. He may already have a preconceived notion that doctors from a top university will always be better, and therefore purposely focuses on that doctor's good qualities and ignores any data that shows bad practice. This would be an example of confirmation bias. There are many more examples of biased decision-making, such as harking, anchoring, and metric blame, that we'll discuss later on. Information gaps, drawing conclusions too early, and biased decision-making are easy mistakes to make. However, knowing how to avoid the pitfalls will ensure you don't make these common mistakes as you continue to make data-driven decisions.